Alright, so welcome back. In this lecture capture video, I'll be going over the three laws, which will also be very important and pertinent when you guys go into General Chemistry 1, which is Chem 110. Okay, so the three laws we'll be discussing in each of their own individual lecture capture sessions will be the law of conservation of matter, the law of constant composition, or also known as the law of definite proportions, and finally it will end with the law of multiple proportion, which, by the way, is one of John Dalton's atomic theory for his model of the atom. So let's just, before we jump into that, just review again what is considered a law. Okay, so a law is a general statement that can be used to summarize observation of natural phenomena. Basically, what it's saying is something becomes a law when the phenomenon that you're observing happens over and over and over, so many times, n number of times. Okay, so like for example, the law of conservation of matter is a perfect one, where after it was performed the first time, and then the 10th time, and then the 20th time, and now at this point 10,000 times, it always keeps happening over and over and over. The matter will always be conserved. No matter what you started from the beginning, as long as it's enclosed, you should end up with the same amount of material at the end by its weight. Okay, so that's an example of a law. So having said that, now let's go into our laws then. Alright, so the first law, which I already mentioned, is called the law of conservation of mass or matter. This was actually based off Antoine Lavoisier, who from 1743 to 1794, by careful weighing the reactants and the products of various reactions, made the following suggestions: that matter can never be created nor can it be destroyed. Okay. Please note here the short time period he was around, because this is around Marie Antoinette. Remember now, where everything back then around the time wasn't going so good for her and any people associated with her, because the people of France were actually very, very poor. And if you guys remember the story about Marie Antoinette, they ended up actually chopping off her head, beheading her, and her husband as well, and a lot of people with her. And unfortunate, Antoine Lavoisier was one of them. So that's just a little backside story, but what you're trying to say here is this: whatever the amount of material you start off with in the beginning, which we in chemistry call them as reactants, as long as it's in a closed sealed container, whatever you do to it, even if it goes from a solid to liquid to a gas, or solid to a gas, whatever change of matter it undergoes of a physical change, the amount of weight from the beginning has to be the same at the end when they form what are called products. Now, mind you, may form brand new items, brand new stuff, but you also will end up with some of the reactions you started off with. Okay, so this illustrates the first law of conservation of matter, which happens over and over, and it's something you guys will be doing for the rest of the time when you guys are doing chemistry. Okay, so here's how we illustrate this law. So, for example, coming here, we have a 0.460 sample of magnesium. So the symbol for magnesium is capital M, lowercase g. That's a solid. Okay, and that amount is 0.406 grams. Okay, reacts with some oxygen. So that's molecular oxygen, O2. This is stuff that naturally exists, and we'll talk. You guys will read and learn later on why this naturally exists in this form and not just O, which is the element, oxygen. But even though they have the same name, please memorize your 7 homonucleotide molecules: hydrogen, H2, oxygen, O2, nitrogen, N2, and you got your halogens. You have fluorine, F2, chlorine is Cl2, bromine is Br2, and finally iodine is I2. So this is a gas, okay? So this magnesium amount will react with some oxygen, and what it produces is something called magnesium oxide, MgO, which we'll also learn later on how to come up with nomenclature for this. That's going to be another very important part that you have to stay on top of as well. Magnesium oxide, and this is a solid. Okay. Well, now we're going to ignore the fact that we're not going to balance anything out yet. That comes out much later. Okay, but this is what we have right now. Reactants on the left. The arrowhead shows you what product shows up on the right. That's always how we do in chemistry. Now you may have one product, or you may form two. So it varies. In fact, sometimes you may start with one reactant that may form 2 products. That's to come later on. Now the amount of magnesium oxide that was formed was 0.674 grams. Okay, so the question asks what mass of oxygen was consumed. So how much of this guy was reacted to actually form this amount? Well, by using the law of conservation of matter, that matter is not created nor destroyed. Whatever amount of material we have in the beginning, we must end up at the end. So we notice here, the total amount, which that's what this is right now, this total, is 0.674 grams. Notice that this number is much greater compared to this one here. So you got to observe here that you have some of this, but you have some of this left over. Okay, X. So all we do is do a little bit of simple arithmetic here. So 0.406 grams plus X grams, we don't know what that is, we're going to solve for, equals this total amount, 0.674 grams. Solving for X, all I do is subtract both sides by this guy. So that goes to 0. 0.406 grams. So what we got left over, remember, keeping track of the rules for addition, subtraction, multiplication, division. This is based on the least number of digits after decimal point, but this is an operation involving subtraction. So we have 3 digits after decimal point here. We also have 3 here. Therefore, the final answer has to have 3 in the final answer. So when we do that, we get an answer of 0.268 grams of oxygen. So that is how much was actually also consumed along with the magnesium to make this amount of magnesium oxide as a solid. Okay, so this illustrates example of the law of conservation of matter. Keep this in mind, please, because this is something you'll be doing constantly over throughout the lecture, right, throughout the whole semester, as well as you'll be doing this experimentally as well in the lab. And of course, this is very important. You got to have this also for when you move into general chemistry 1 and 2 for the rest of your pretty much time doing anything associated with chemistry here. Okay, so with all that said, I'll end that here, and then we'll move into our next discussion. I'll allow a different portion in next lecture capture video.